Alright, so let's talk about isotopes. So isotopes are atoms of the same element having different mass number. So let's say we have an element A. So isotopes, they have the same atomic number but different mass number. So let's say we have hydrogen atoms. So we have hydrogen 1, we have hydrogen 1, 2, and we have hydrogen 1, 3. So this is hydrogen, this is deuterium, and this is tritium. So these are isotopes. So they have the same atomic number, which is the same number of protons, but different mass number. So the different mass number is as a result of different number of electrons. So here we have that proton is 1, therefore neutron is mass number minus proton, and that's 1 minus 1 to be 0. So for this, proton is 1, so neutron is mass number minus proton. Recall that mass number equals to proton plus neutron. So we have the neutron here to be mass number minus proton. So we have 2 minus 1, and we have 1. So also for tritium, we have proton to be 1 and neutron to be 3 minus 1. So we have it to be 2. So all of them have the same atomic number but different mass number. And a different mass number is because they have different number of neutrons. So here are some characteristics of isotopes. So 1, they have the same number of protons, same number of electrons. So isotopes of the same element have different neutrons. So take note of that. So we also have that isotopes of the same element have similar chemical properties. So take note, here is these are isotopes of hydrogen. So even though they have different number of neutrons, they have the same chemical properties regardless. So isotopes, they have the same chemical properties, although their physical properties may vary. Alright, so let's solve some question. So a sample of neon is found to consist of these isotopes in the following percentages. So calculate the relative atomic mass of neon. So the first thing you need to take note here is the formula for calculating relative atomic mass. So we have that R.A.M equals to the summation of the mass of each isotope. So this is an isotope, this is another isotope, and this is also another isotope. So this is the mass number of each isotope. So the mass summation, that is the summation of the mass number of each isotope times its relative abundance. So the abundance. over the summation of the relative abundance. So in this question, we have that the relative atomic mass to be 20 times 90.92. So this is the mass number. We multiply it with its abundance plus, so let's put a small bracket here. So plus 21 times 0.26, and then plus 22 times 8.82. So we have everything all over the summation of 90.92 plus 0.26 plus 8.82. So this therefore becomes 1818.4 plus 5.46 plus 194.04 all over. So this is for all over 100. So we have our answer to be 20.18. Alright, so let's look at this question. The relative atomic mass of potassium is 39.1. So calculate the relative abundances of its two isotopes in a sample of potassium. So let's have our solution. So first of all, relative atomic mass equals to the summation of the mass number times abundance. So summation of everything, and then we have a summation of the abundance. So it is nice to see that the summation of the abundance is 100%. So we have that equals to 100%. So therefore, we can see that for this isotope, let's assume that its abundance is X%, and let's assume that the abundance of this isotope is 100 minus X percentage. So therefore, we have that the relative atomic mass to be 39.1 equals to the so we have minus 39 times X, 39 times X plus 41 times all of this. So we have 41 100 minus X, everything raised to power, everything all over 100. So therefore we have that 39 1 new equals to 39x plus 4100 minus 41x. So we can therefore say that 39 1 new minus 4100 equals to 39x minus 41x. So therefore we have that this becomes minus 190 equals to negative 2x. So negative cancels negative. This one cancels this. We therefore have x equals to 95%. So if x equals to 95%, therefore x minus 100 will be 100 minus 95. So it will become 5%. So this is 5%. So this has an abundance of 95%, and this has an abundance of 5%.